go through all these things, whatever we discuss, and will from tomorrow onwards, it will be full-fledged coding. Okay. So till now, what we discuss about Spark architecture. What do you mean by Spark architecture and all these things? Basically, whenever we are discussing all the concept related to Spark, we mainly the Spark is meant for your data processing. So, okay, let me look for the PPT. There is one more thing. Give me a second. Okay, let me summarize here what we are seeing that if you will gonna see the Spark is meant only for processing of the things. So underlying storage, any data related project comprises of another thing. What is the processing of data? So here what we are doing inside our curriculum or maybe 90 to 95%, you will find a distributed file system layer. For Hadoop, it is HDFS. Maybe for AWS, it is S3 bucket or blah blah things. Or maybe for Google Cloud, it will be the cloud storage. So you will find a distributed file system layer. Then on top of that, for data processing, I have a Spark engine. Okay, I have a Spark engine on top of your DFS. Okay. So if I'm gonna use this one, is my Spark is meant for only data processing or storage for processing? My Spark is a tools or a framework which is only and only meant for your data processing. I don't need to bother about data storage, where my data used to store. Okay. So if my data processing engine, so do you think there will be any name node, data node, and all these concepts? No, there won't be any kind of name node, data node, but this framework uses the DFS name node, data node, and blah blah things. Because I have used the DFS architecture like our HDFS architecture. If you do remember, inside our HDFS, we discussed there is one name node and n number of data node is associated with that particular of name node. I'll not go through that block size and all these concepts. So whenever there will be a block will comes, that will be 128 MB blocks, how this will gonna store, you know better than me. So here my data storage happens. Now after that, what I will gonna happen? On top of these data storing mechanism, there will be a Spark software installed in each of the where each of the nodes. So inside my cluster, this is a 4 node cluster, one name node and 3 data node. So my Spark software, I have to install each of the name node as well as in data node. Here is my Spark. Okay. If we start processing of your Spark previously inside my Hadoop, which is the processing engine, there is a term called as MapReduce. If you do remember what MapReduce will do, sorting and supplying, correct? Yes and yes. There are two things. Mapper phase, there is one reducer phase. Inside that, there is sorting and supplying, and all these things have happened. So inside my Spark, this all the concept is no more uses. So Spark is has its own architecture. So if I jump into the Spark architecture, how Spark behaves. So just see the Spark, yeah, this is your Spark architecture. Okay. Spark architecture comprises of three things. What is that? The first and foremost thing is that your driver program. What do you mean by driver program? So if you do remember inside our Python function, there is a function definition. Correct? What is function definition? This starting of the function is known as a function definition. So the moment I will define the function, that will be the entry point to the function. Am I correct? Function definition is always the entry point to the function. Similarly, the driver program is your entry point to your Spark framework. So let's see here. Okay, let's see. It's the moment I submit a job, the moment I submit a job, the fast thing, let's say, for example, I have a.py file. Why I am writing a.py file? Because all my codes inside my Python file. The moment I'll submit a Python code, so what it will do? The code is a driver function. So what is meant by driver function? Maybe a function, something which will initialize. The fast and the posting is your driver program. The driver program will initialize Spark context. What do you mean by Spark context? Spark context. Here, the fast thing, the driver program will get execute. That driver program once will get execute, it will initialize the Spark context. Spark context is nothing but to entry to your Spark project. Just like your this architecture, you can compare with any kind of zoo or any kind of garden. The moment you will buy a ticket, you can go entry to your garden, correct? So Spark context will be treated as your gatekeeper, or you can say a ticket. Driver program is nothing but your ticket, and Spark context to do your entry through your gate, correct? The moment you show to the gatekeeper, I have the ticket. Similarly, the Spark context will initialize the Spark framework. What do you mean by cluster manager? So in HDFS, what is the cluster manager we discuss? We discuss YARN, correct? What do you mean by YARN? Yet another resource negotiator, correct? So it is only and only applicable for maintaining the cluster. Just give me a second, guys.
Arrow entry points.
Yeah, Anvesh with that.
Yeah, just give me a second, guys.
Entry.
Okay.
So inside our Hadoop architecture, what we discussed, there is a cluster manager. What cluster manager is responsible for?
Hey,
The cluster manager.
sorry to interrupt you. I have one question. You say like this a.py, right? So where do you submit that a.py? You write a Python code. In that code itself, you have to write a driver program and Spark context.
Yes, yes.
And
Okay, I'll also just okay. I'll show a code, Python code to a Spark code to you. You will find. I'll also at the time of submitting a code, I'll say. So what do we
okay.
have to say? You cannot go ahead directly submit your things. So at the beginning of any Spark code, okay, at the beginning of your any Spark code, you will find a altogether a set of functionality. So it's a predefined how to initialize the Spark context, how to initialize the worker node, how to initialize the driver program, and all these things. Okay, I'll show it maybe in the one or two classes. After that, what will happen? So the Spark context will communicated with the cluster manager. So what do you mean by cluster manager? Who will responsible for means who knows that okay, let's say for example, which file is where, which is the development file, all these things. All together, the your you can say your storage level action will be taken care. Storage level metadata information is with your cluster manager. So there are different kinds of cluster manager, like your Mesos is there, like Kubernetes is there. But here inside our Spark or inside your Hadoop, you will find YARN. YARN is our cluster manager. It's no which file is in which worker node or your data node. Okay. So now my task and the executor will gonna happen. The you can say this is your worker. This is your master. Sorry, the master is having your driver program. Similarly, inside your worker, you have your executor. Correct. Who will do this? If you do remember, if I compare your master slave architecture with your here is my name node. Am I correct? Compare with your HDFS architecture to your Spark architecture. Which is master here? My name node is your master. Similarly, inside your Spark, this is my driver program. This is my worker node. Inside my worker, there are executor. Got it? These are my executor. These are my executor. These are my executor. Who is worker here? This is my Spark diagram. This is my Hadoop HDFS diagram. This is my name node. This is my worker node. Correct? This is my worker node. This is my worker node. So here in this is your Spark software installed in each worker. Spark software installed in each thing. Spark software installed in here. Perfect. This is my executor. This is my executor one. Executor one. Each worker node, you will find a one executor. For whole program, there will be one driver. Okay. But a worker node can have multiple tasks. What do you mean by task? The lowest granularity of our work is known as a task. Let's say, for example, just like your sprint task. So, if you are doing a project, we have sprints in our agile method, correct? So, each sprint is a task. And in a sprint, you may take up 4 tasks, 5 tasks. That is kind of an executor, correct? This kind of an executor. So 4 sprint. Okay. Each Jira story is a task. Each sprint is an executor. Got it? Maybe in a executor, I have multiple Jira story. Let's say, for example, inside this sprint, I have 10 Jira to solve or 5 Jira to solve. So each Jira will be, you will treat it as a task, and each multiple Jira will comprises to give out a executor. What do you mean by cache? Cache means the as simple as your permanent storage of your output. Let's say for example, cache. As simple as that. Whatever cache in general statement, that cache is applicable. Let's say for example, you submitted some code and you get some output. You want to persist it or you want to store that output. You will build a cache. So what is the beautifulness of your cache? Because if you do remember inside our past classes, I given an example of in-memory data processing. What do you mean by in-memory data processing? Whatever the data you will process inside your Spark, that of the things will be processed only and only through your RAM. That is known as your in-memory processing. If I do remember, if you say, if I'm gonna ask you, can you give me the country and its capital for 210 country? Is it very difficult to process? Right? So the more time you will by heart all these things, at the end of the things, you will by heart all of the state and its capital or country at its capital. This is known as your cache. Let's say, for example, you are repeating the same task again and again, again and again, again and again. So after 10 execution, again you go ahead and execute the task. Do you think the input data remains same? The input code is remain same? Do you think this is gonna execute one more time and think the data? No. This will go directly to your cache, read the output from the cache. Got it? What do you mean by cache? So in this architectural diagram, do you have any doubt or anything to be discussed?
No, so it cache over there, and then next time onwards it will be fast, right?
Yeah.
That's what.
Yeah.
Okay.
Yeah, perfect. It will be kept. But there is a one constant that the input file and the input code remains constant. Correct. Let's say,
Okay.
for example, one time you hit the employee table. Second time you are hitting the department table. Do you think cache will be coming into the picture? No. Here my input data is employee, here my input data is department. Got it? The input data and the input code, if it's remain constant, then my cache will comes into the picture. Okay?
Otherwise, so one time we query input employee input data, and otherwise we query something else, then it won't go to cache. It always treat as a fresh.
Yeah. No, you didn't. Let's say, for example, I have inside this my worker node, I have an employee table, I have a department table. Correct? Okay.
Okay.
One time you were hitting employee data, so you got some output that you cache. But the second time you are hitting department table. So if I'll go to cache, I want a department information. How I'll get it from the cache? I won't get it from the cache. Can I?
Oh no.
No. That's what I'm saying. So again, let's say for example, in some code, you are write a group by function, but another code, again, if you are writing the same table also, you are writing some sum. Maybe one time you are taking sum and another time you are taking average. Do you think this code will be remain constant? No, the code is getting changed. So my cache won't get useful, correct? So the input
Okay.
of data and the input code will remain constant. So this is what your architecture of your Spark. Then we have discussed the benefits, or you can say the I'll say the features of Spark. So what are the different features of Spark? The first thing is there is a it works on a concept called a DAG. What do you mean by DAG? DAG is nothing but a directed acyclic graph. What do you mean by that DAG? So let's say, for example, this diagram. You see, there is a input. Okay. What do you mean by RDD? Before going to that, what do you mean by RDD? RDD is nothing but a small chunk of input transformation thing. So what is that input transformation? Let's say, for example, you first will understand what RDD. I think all these things we already been discussed. Today I'll just summarizing the things from tomorrow. No need. Okay. Let's say, for example, I have a file. A.txt. I want to process this file inside my Spark framework. So can you go ahead and directly? No. The Spark is only know one thing, that is known as your RTD. Okay, resilient data set. Resilient distributed data set. What do you mean by resilient? What do you mean by distributed? And what do you mean by database? So we know already what do you mean by distributed. If the work is distributed among n number of things, that is a distributed. Okay, what do you mean by resilient? Resilient means fault tolerant. How it is gonna achieve, I'm gonna show you. Okay. And what do you mean by dataset? Dataset is a specific information. Okay. If you want to process a.txt file inside your file, inside your Spark framework, the first step to process is to create a RDD out of that any input thing. Correct? To create a RDD out of anything. What is the way to create a RDD? Basically, there are two ways. One is dot text file method, another is parallelize method. What do you mean by parallelize method and what do you mean by text file method? If it is a file, okay, if it is any file, then which concept you will apply? Dot text file method you can apply. Okay. If it is a Python iterator or any iterator, I'll not say Python iterator, but for our convenience, as we are doing PySpark code, so any Python iterator. What are the different Python iterator? Tell me. list is a iterator, tuple, set, dictionary, all these things are your Python data types or Python iterator, correct? Or range function, all this. So whenever I'm reading the data from your iterator, this will be through your parallelize method. Once you apply your parallelize method, you will create a RTD. Perfect. Any doubt? See this. So I have a input one, I have a input two. From your input can be a Python iterator or anything. From this input, I have created a input RDD. From here, I have created a RDD. Then I have created, let's see this one. I have sourced data. From this source data, I have created a data 1 RDD. From this data 1 RDD, I have created a data 2 RDD. I have created a data 3 RDD. Okay. So you can create RDD in three ways. The first way is that from a dot text file method, then your parallelize it method, and from a RDD you can create a RDD, another RDD. Got it? From a RDD you can also create another RDD. With this scenario, which is the RDD, which is the base RDD of data 1, data 2, tell me. Data 1 is your base RDD. Am I correct? Am I correct? Yes.
Yeah,
So
yeah.
inside that, what happened? If you have a base RTD, the base RTD will be formed from your inputs file or input. From your base RTD, you can create a number of RTD. Okay. But this RTD follow a method or a way that is known as called as your DAG. What do you mean by DAG? So it will always follow a directic acyclic graph. So what is that? Let's say for example, like so here. I have a RTD1 here, one RTD. I have created RTD2, and from this RTD2, I have created 3 and 4. Okay. If I want to get the output, okay, right, output OP1, OP2. Okay. If I want to get OP2, what is the step I will follow? Tell me.
What's the
So I
question,
have
Anvil?
to go from source to 1, 1 to 2, then 2 to 3, and 3 to output 2. Correct? If I have to follow. If I want output of OP1, so which steps I have follow? I have to go to source to 1, 1 to 2, 2 to 4. Correct? Okay.
Yeah.
But at this moment, let's say for example, at any moment, my RDD2 is done. Means it's died or it's lost. So can I get the output OP2? No, you can't get it. So for that, what I need to do? I have to go to
Yes.
step 1 or RDD1 and I have to create another RDD2. Correct? How can I create an RDD2 from RDD1? Agree? I have to
Yes.
create RDD2 and from this RDD2, you have to create a OP. Let's say, for example, this is one type of diagram. Let's say, for example, there is a source file. Okay. From that source file, see, I have created a RTD1. Okay. From RTD1, I have created RTD2. Okay. From RTD2, I have created RTD3. And from RTD3, I have created RTD4. And this 4 will connect it to 1. So at this moment, if I want to see, let's say for example, okay, there is OP1. From here, I am taking output 1. Okay, output 1. If I want to take output 1, how I will gonna achieve? I have to go input 1, 2, 3, 4. then output. Agree?
Yes.
But at some point, due to any constant, my RDD2 is lost. My RDD2 is lost. Similarly, can I able to get the output? So what I need to do?
To create RDD2
Again, I have to create a RDD2. How I will gonna create a RDD2? Tell me.
from RDD1.
From RDD1, correct?
But
How I will gonna?
why we need to create different RDDs?
Okay. Why we need to create a different RDD? Actually, the Spark framework, okay, it's already been discussed, but still I'm going with that. Actually, what happened inside your Spark, there are two concepts. What are the two concepts? One is transformation, another is action. What do you mean by transformation? Transformation is your editing. Let's say, for example, you want to edit something from this input, you want to edit something. That is your transformation. Action is nothing but your command. Take, count, and all these things are your which concept? Your action. Let's say, for example, I have a file called product file. Okay. Product file. Okay. From this one, what will happen? This have all the information related to all the products. Perfect. So in the first thing, what I want to create, I want to create a RDD, okay, which will contain all Asia information. Okay, you created. Then what will happen? I want to create one more thing which will contain all South Asia information. Okay. Then from that, I want to find one more input which contain only India information. Okay. And from here, I want to find all maybe east east side India information, and from here I want to find all the northeast information. Got it?
Hmm.
So from this product table, I can come directly to the northeast information. Agree?
Yeah.
Yeah.
But if you will do all these things in a single go, it will take too much time or not?
Correct.
Perfect. So that's why here I am just editing something. I am creating a RTD1. Okay. Here I am editing something. I am creating RTD2. Okay. Here I am creating something India information RTD3. Here I am creating something. I am creating RTD4. Okay. Here I am creating something. I am creating RTD5. Okay.
But
Let's
how
say,
there is a separate step you are filtering in each RDD to do that?
yes, each RTD. So
For
for
example, A, you said South Asia in so in the A we have four then, right? Like whatever four directions of Asia, we put four RDDs and top of that means you branch out like accordingly.
sorry. South is, yeah. If you want to take this information, so where I need to filter, tell me. I have to filter Asia one, correct?
No, but in design, in design you do like this in Asia. Let's say we
Uh,
have South Asia and North Asia, right? So you put
uh,
now two different RDDs in the Asia, and then you in South Asia you branch out like you shown here on the diagram. That's how you like design this thing, this whole concept.
huh. No. Okay. What? Let's say, for example, I required my northeast information, correct? So what is the path you have to? Let's say, for example, somewhere you want China information. So what I'll do? From your Asia information, you will create one more branch here, or you can say here you will write your maybe I'll say that North Asia information. Correct?
Okay.
This path is independent. Let's say, for example, from North Asia, you will want to find China. From China, maybe you want to find North China or coastal China or East China. I'll write East China. Then from here you will find Beijing. Got it? So this pipeline, or you can say this RDD branch, is not anywhere related to this one. So I want Beijing information, then I have to follow this path. Agree?
Correct.
Yeah. Okay. The agenda here, what I am trying to show you that, okay, at any moment, let's say for example, then here I know about my northeast, then I will do, let's say for example, I want to find the number of products sold in northeast. So what you will do, you will write a action. So here all these are transformation. All these are transformation. Got it? Unless until you press a action, this transformation won't get executed. This is known as your lazy evaluation. Correct? What do you mean by lazy evaluation? Unless until you do a action, no transformation will gonna execute. That is known as your lazy evaluation. Perfect. So these are all in graphical structure, but at present nothing gonna execute. No code level will gonna execute. The moment you will start executing the action, this transformation 1, this transformation 2, this transformation 3 will get executed. Okay. So what I was trying to show, let's say for example, at any moment, okay, at any moment, my RDD3 got died, or it is no broken, it is no of uses. So how can I retrieve RDD3 information? I have to take a step back to RDD2, then I have to apply the transformation, correct? Then I have to create a new RDD3. Agree? I agree.
Yeah.
Yeah. Okay. But the same diagram, the same diagram, what I will do from this, okay, let me connect it to here, okay, let me connect it to here, and from here I am taking some output, okay. Here I am taking action, at this moment I am taking this output, okay. See the green line. I want this action and I want this output. How I will execute and find my, okay, this is what the process, but some point what happened, my, this one died. RDD3 died or RDD3 broken. So how can I get the output? Tell me.
SA2.
No, you have to
From
create.
SA2 I will create. Okay, from SA2 I will create. So how I will create? Is only RDD3 is getting created from RDD SA2 or from any 5 also?
Any also.
No, but
From
you
any
get
else.
the transformation from SA2 only, right?
No, you can say how many incoming arrows are there?
From S and any. 2.
There are 2 arrows. Correct. I cannot create I3 only from SA2. I have to create a combination of SA2 and NE5.
Okay, okay.
Got it, Sanket? Or you are
Yeah,
still confused?
no, but let's say if you created I3 from SA2, then the I3 data got filtered in E1 and E1 then data filtered more to NE. Now, how we want to create now another I3 based on SA2 plus NE?
That's what the concept. So that's what I'm saying. This is a cyclic graph. This is a acyclic graph. Got it? So RDD cannot be a cyclic manner. That's what my agenda is. So whichever in your program, whenever you will create a output based on the RDD, it should follow a acyclic graph. That's what the name suggests. Directed acyclic graph.
So in
So-
cyclic, you cannot do it.
In a cyclic, you cannot go from northeast to that one, right?
Yes. No. What in acyclic?
In a cyclic, you cannot create I3 from any, but in cyclic, you can create.
Yes. In cyclic, I can create I3 combination from SA2 and NE5. But in acyclic, I cannot create I3 from NE5 northeast. That's what is
Why is it cyclic then, right? What is the use of cyclic?
no. That's what I'm saying. It shouldn't be a cyclic. It should be a cyclic. If you are doing this way using Spark, it's a blunder. That's what I'm trying to say. Spark will never and ever will follow a cyclic graph. It is always a cyclic graph.
Okay.
So
Understood.
whenever you are creating a RDD from another RDD, it should follow the cyclic graph. That's the feature. That's what it's showing. So this is a cyclic or acyclic. This is a acyclic.
Cyclic.
No, there is never ever cycle formation. Correct. This is coming this way, this is coming this way, and it's a cycle.
Yes.
Correct.
It's a kind of okay. If we like so yeah, if you see, this is a cycle. Correct.
So you cannot do it here.
You cannot do like this. So this is what your RDD and all these things. Okay. Lechi evaluation and all this. Okay. So tomorrow we're gonna see your Spark and all these things. I think Sanket, these things I've been already discussed with Hardik. Just please go through the recorded session. If not, maybe tomorrow we will go more into your what do you mean by action and transformation. Then all the related code related to action and transformation. Perfect. And this is a request. So please by tomorrow just check with your Databricks account. If not, tomorrow Anna fast fix the Databricks account information. So are you able to log in into Databricks? If not, so we'll create the first and we'll start writing the code.
Okay, I already have. So
Yeah.
yeah, I will
Mr.
go through the
Sir,
video today night.
Sure. Yeah, please go through all these things.
Okay, thanks.
Okay, thank you. And I think from tomorrow we'll connect from 8:45.
Yeah.
Yeah, thank you.
Thanks.